Welcome back, students. In this video, I will discuss the most common mistakes, tips, and your cheat sheet for this trigonometry chapter. So, for this chapter, you must familiarize yourself well on the trigonometric identities. There are three identities. Not only this identity has multiple forms by simplification, reorganization, all that. All those forms are discussed in part number 9, 10, and 11 of this video. Please go through this video, write and practice one or two times the different forms so that the moment you see any of those forms, you can relate to which identity it belongs to. The second important thing which you are supposed to know is all the angles memorized for every trigonometric ratio. At the minimum, you are supposed to know at least the sine, cos, and tan. Excuse me, so that you can arrive at the other one with the inverse. But memorizing everything is preferable. One important tip: wherever possible and needed, draw the right angle triangle, mark the value of the hypotenuse, opposite side and adjacent side. This will reduce the chances of making mistakes when finding the value of trigonometric ratios. Instead of opposite side, you might wrongly substitute the adjacent side values. So those can be avoided. So one sample is, say here it is written ABC is a triangle, right angle at C. Right angle at C is the key because at C is where the 90-degree comes. And you're supposed to find the value of cos A plus cos B. So putting a drawing and mentioning what is the value, like whether it is whatever it is, 2, 3, 5, whatever is the value. If you mention it, cos A you can easily find out by viewing the triangle from here, and cos B you can find out by viewing the triangle from here. So without this diagram, it's highly possible you will make a mistake. Similarly, this is a second sample. It's a right angle triangle at B. Note the point, it is right angle at B. So you'll be showing the 90 degrees at B. And again, here too, you are supposed to find the value of tan A into tan C. So both are again opposite. So you are supposed to derive one equation by having the theta here, and another equation or another trigonometric ratio by viewing the theta here. So drawing the triangle helps you much. This is one third sample. They have given you the value of theta, that is 3 by 5, but you are required to find out the value of alpha. So putting this in place, which is the hypotenuse, which is the adjacent side, that helps you to properly figure out like what you're exactly supposed to find out, which is your adjacent side or which is your opposite side. So drawing the diagram is one important thing which you're not supposed to miss. And when you try to solve equations, always start from the left hand side, not on the right hand side, as far as possible. Solve the left hand side and show that its value is being equal to the right hand side. And again, you cannot treat a trigonometric ratios or a trigonometric equation like an algebraic equation and switch over the terms. For example, here you have tan theta plus cot theta. You are supposed to prove this LHS is equal to this RHS, that is sec theta into cos theta. So you have to work around this left hand side and show somewhere by simplifying solving, you have to show this left hand side is equal to right hand side. But do not, like algebra, do not take this cot to the other side. See, for example, this is the wrong approach. Tan theta is equal to, the cot has been taken to the other side, which is wrong. You are not supposed to do that way. I have discussed in detail in my 17th part video on how to approach the different trigonometric problems. What are the tricks or what approach you have to take. So that video description also has a download link. Please do not miss the download link. That download link has the complete PDF of the approach whatever I am discussing in this part 17. Then comes the mistake 1. So common mistakes what students make is confusion with the trigonometric identity sequence. On the left, whatever you are seeing is correct. 1 minus cos square theta is equal to sin square theta. 1 minus sin square theta is equal to cos square theta. So all these are correct. But on the right hand side, whatever you're seeing is wrong. Means this cos and minus one position, cos and one position is interchanged, if you can see here. So this is not same as sine square. It's cos square theta minus 1 is not sine square theta. In a hurry, you should not somewhere substitute this value as sine square theta. Ideally, this value should be minus sine square theta. Same way, tan square theta minus sec square theta is equal to 1, but not sec square theta minus tan square theta is equal to 1. It is actually minus 1. So whenever you find this interchange position, be a bit careful. This is the right sequence, whatever you see on your left, and whatever you see on the right is a wrong sequence. Not a wrong sequence, it's a wrong value. Sequence could be anything. Sequence can be anything here, but you should not equate it to 1. It should be minus 1. So be careful about that. Another mistake is you might somewhere land in a scenario where you have 6 sine theta whole square plus 6 cos theta whole square. Mistakenly, what people do is they don't square the 6. They pull out the 6 outside. Sine square theta plus cos square theta is equal to 1 and the value is 6. But the actual right thing you're supposed to do is you are supposed to square the 6 also. So it becomes 6 square into sine square theta plus 6 square into cos square theta, which is equal to 36 sine square theta plus 36 cos square theta. Then you pull out the 36 and you get the answer as 36. You should not miss to square this 6. Most interestingly, in a multiple choice, you'll have even 6 as option and you'll have even 36 as option. You may be tempted to choose the 6 as an answer. No, you should have squared the 6 and the answer should be 36. Then when squaring both sides, for example, whatever you're seeing is a minus b whole square formula. Somewhere you should not think that sine theta minus cos theta whole square is equal to sine square theta minus cos square theta. No, it is actually sine square theta plus cos square theta minus 2 sine theta into cos theta. These are the mistakes which have happened in the past with some of the students, which I am trying to highlight it. And again, this 1 plus sine square cos square theta becomes 1. And so whatever you are left is 1 minus 2 sine theta into cos theta, which is the right value and not sine square theta minus cos square theta. So thank you friends. We have almost completed the trigonometric identities. In our next videos, we will solve any problem which is left out or the sample board problem for 2026.